Hello, everybody. Welcome to our Fireside Chat entitled Best Practices for Cost Optimizations for the AWS Database Portfolio. My name is Jagdish Marani. I'm your host today. I'm part of the product marketing team here at AWS. I have with me Vlas Chanyu. He's a database specialist, and I'm going to have him introduce himself. Vlad, go ahead.
Hi, Jag. First of all, thank you for having me here today. I am the tech leader for databases here at AWS, and I lead the internal community of subject matter experts in the area of databases. We work closely with customers to provide in-depth expertise and help them adopt our managed database services. We also work really closely with the service teams, influencing the future direction of our database services based on our interactions with customers. I've been with AWS for 9 years, and I started my career here at AWS as a solutions architect, helping customers adopt our services. But over time, I focused my work more on databases.
Great. So 9 years, that's like half the life of the company.
Yes, it is.
You're definitely the right guy to have here as the guest for this particular topic. So we have a lot to cover here, and let me kind of give you a quick view as to the things we're going to hit. In terms of cost optimization, there are many levers you can pull, choosing the right infrastructure, optimizing your license structure. In-memory caching is a very popular way of containing costs. Database lifecycle decisions, of which there are many. Monitoring and tracking your cost metrics so that you know where your costs are and what's driving your costs and where you can optimize costs. And using tools like pricing calculators, estimation tools. So there's lots of ground to cover. And so let's start at the top, Vlad. Choosing the right infrastructure. What are some of the considerations around this, and what does this amount to?
Well, first and foremost, if you're self-managing your databases today, you can realize immediate benefits by moving them to fully managed databases. Our managed database services remove all of the tedious work you have to otherwise do when you manage your own databases on a day-to-day basis. Dealing with backups, patching, operational monitoring, and so on. All of these are activities that AWS can handle on your behalf with our managed database services, and that allows you to focus on activities that bring value to the business, like workload optimization. Now, initially, you have to choose what database to use. And if you don't plan to make any changes to your applications, you simply adopt a managed database version of the same database engine that you're using today. We offer the broadest set of options with managed database engines for Oracle, SQL Server, PostgreSQL, MySQL, and MariaDB. And we even have a MongoDB-compatible database called DocumentDB. Now, if you plan to modernize, we have even more options with services such as DynamoDB, Neptune, TimeStream. Moving to a managed database, you'll need to choose an instance class and an instance size. Instance classes have different capabilities in terms of CPU, memory, network throughput, I/O throughput, and so on. Within each class, there are multiple sizes, but they're all going to have the same proportion of compute capacity, vCPUs, to memory within that same class. Typically, the amount of compute and memory doubles, as you're moving up from one size to another, but not always. Now, making the right choice can help you with optimizing your costs, as different workloads need different proportions of compute, memory, and throughput.
Cool. So you have a lot of choices here, not just in the style and type of database, but the capacity and the instance style and instance size, et cetera. So in terms of our instance style and instance sizes, That's not a static list. We keep adjusting that based on need.
Mhm.
And so we recently added a instance type for IO intensive workloads. Can you give us a synopsis of that?
Sure. Amazon Aurora, which is our MySQL and PostgreSQL compatible cloud native database service, has added a new configuration called Aurora IO Optimized. It enables customers to improve the predictability of their database spend. Typically, customers with IO intensive workloads or highly variable workloads used to find it very difficult to predict their spend and how much their database resources cost. Now, with Aurora IO Optimized, customers simply pay for their database instances and storage, and there are no charges for read and write IO operations, unlike the standard configuration. With this improvement in price performance can result up to 40% cost savings when IO spend exceeds 25% of your total Aurora database spend.
So the cutover is about 25%.
Right.
If 25% of my spend is on IO, then it's worthwhile looking at IO optimized instances. And I would imagine that applies to a lot of people. And that 40% saving is substantial.
Definitely.
There's another area where we offer substantial savings, and this is something maybe a lot of people don't know about, is that we have our own processors called Graviton processors. So can you tell us a bit about Graviton and how that helps customers cost optimize?
Absolutely. So Graviton are AWS designed processors optimized specifically for performance of cloud-based workloads running in Amazon EC2 or some of our other services. We are currently offering the third generation of these processors called Graviton 3 in both Amazon RDS and Amazon Aurora. In most of our database services, we also offer the Graviton 2, the previous generation as well. Now, Graviton 2 offers 52% better price performance on Amazon RDS and 35% better price performance in Amazon Aurora. Graviton 3, in turn, delivers a 20% price performance improvement versus Graviton 2 in Aurora and a 27% improvement in Amazon RDS for the open source databases.
Wow, those are not small numbers, and the cumulative effect is substantial. If you're using Graviton 3, then you've got some major performance improvements that you can anticipate.
Absolutely.
So all of these choices are great, Vlad. But if I'm coming in to the AWS environment for the first time and I don't have a good indication of what choices to make, which instance classes and sizes to choose, how do I go about making a choice?
So there are a couple of options available to you, but it will ultimately depend on the application and how you plan to use it. The way I like to frame it is you can think of it as a spectrum. On one end of the spectrum, if you plan to deploy net new commercial off-the-shelf applications, the vendor typically provides guidance on how much capacity you would need in different types of scenario based on numbers of users, throughput, and so on, right? Follow those recommendations. That's going to be your best starting point. Now, on the opposite end of that spectrum, if you plan to deploy an in-house application that is developed by you, and you might not be able to predict adoption and how it's going to be deployed or used, consider using our cloud-native services that have serverless configurations, where you pay only for the capacity that you consume. Aurora Serverless version 2, DynamoDB on demand, Neptune Serverless are all great options, depending, of course, on your use case. And in the middle of that spectrum, it will probably depend on what data you have, and most likely you should run a POC. Start with one instance types that you feel closely resembles what you would need, and then adjust from there.
So, despite my best efforts in following vendor guidance and running a POC, etc., suppose I still get it wrong.
So you can easily change your instance class and size to a larger or smaller instance with a few simple clicks in the console or, command line with API calls. This is an example of vertical scaling. You would essentially replace the instance with something bigger or smaller. You can also horizontally scale in or scale out by adding or removing nodes from a cluster if you're using a database service that actually supports that cluster concept, such as Elasticache for Redis, or even Aurora for read replicas for that matter.
Mm-hmm. There are a lot of database engines in the portfolio. Let's start with DynamoDB. We'll come to the others in a moment, but there were a couple of improvements to DynamoDB that deliver better price performance, and these were recent changes. What were these?
Yeah, so the DynamoDB standard infrequent access table class is ideal for use cases that require long-term storage of data that is infrequently accessed, right? Things like application logs, old social media posts, e-commerce order history, past gaming achievements, and so on. If you think about it, most workloads, as you're accumulating data, the older data gets used less and less. So DynamoDB standard infrequent access could be a great choice for those types of workloads. And with that option, you can save up to 60% in cost compared to standard DynamoDB tables. And also, DynamoDB has a new feature where you can import directly from Amazon S3. And that one delivers a 66% cost saving versus you loading that data via the client-based writes, using your table's provision capacity.
That's great. So 60% and then 66% using S3. Those are some pretty good cost savings. What about licensing, Vlad? Are there any licensing structures that offer discounts for commitments and things like that?
So we do offer discounts for commitments. Think of it this way: AWS benefits from long-term predictability of capacity usage. And in turn, we can pass those savings back to you as the customer. AWS database reserved instances give you the option to reserve a database instance for a 1-year or 3-year term, and in turn receive significant discount compared to running those instances on demand, on an ongoing basis.
Right. So Vlad, if I've tried really hard to characterize my workload to figure out exactly what kind of capacity I should secure, and I just can't because there's so much variability. I have bursts of activity related to software release process where my development team may be doing some testing. I have seasonality related to my business where there's a spike in activity because of special days like holidays or just sales or Christmas, etc. And I just cannot identify a workload that is stable enough for me to choose my capacity. What do I do in that instance?
In that case, a serverless database is your best option. With serverless, you can save up to 90% of the cost versus provisioning for peak capacity on Aurora, Neptune, and some of our other instance-based services. Switching back and forth between serverless and provision capacity for Aurora and Neptune is also easy. So you can start with provision instances and then switch over to serverless, or you can do the other way around. You can start with serverless and switch back to provisioned once you learn, or if your workload pattern changes such that it is more predictable. You can also combine RI-based capacity, reserved instances, with on-demand capacity. Say you have a steady state workload that for 10 months of a year, right? But over the last 2 months, let's say during the holiday season, you see a dramatic higher level of utilization, potentially even variability. You can secure reserved instances for the steady state capacity and then scale up using on-demand capacity for the holiday period. This mix of reserved instance usage and on-demand capacity may also be more cost-effective than provisioning for peak.
Yeah, I would imagine provisioning for peak is really sort of over capacity for the rest of the time and fairly costly. It's great that our customers can remain nimble and choose between reserved instances or on demand and serverless, and it's convenient to be able to do that because you may need different things at different times. Vlad, we talked about DynamoDB briefly. Let's talk about some of the other database engines and databases. RDS, for example, there are separate considerations related to compute and storage for cost optimization. You kind of have to look at compute and storage separately. Let's start with compute, and let's talk about compute and how you can optimize your compute resources for RDS. And let's use RDS as an example.
Yeah, I mean, we already touched upon some of them, such as the reserved instances or using serverless capacity, but there are several others. Right sizing is the mechanism to adapt your capacity to the actual consumption. Use the right amount of CPU and memory. You can scale down if you see consistently low CPU or memory utilization, for example. Now, when I was helping customers cost optimize, I usually found a couple of databases that had intermittent load. These were used only at certain times of the day or maybe only at a certain times of the week. Maybe it's a payroll system that only runs once a month or every 2 weeks, depending on the pay schedule, right? Consider stopping and starting back up such databases only when they are needed. The other aspect is query optimization, right? That's also a mechanism to reduce the load on the database and in turn potentially make it fit in a smaller instance size.
Great. So stopping and starting is definitely something that people can do to vary their workload and tuning SQL queries as well. What about on the storage side? What can people do to optimize their storage costs on RDS?
So RDS offers several types of storage with different storage characteristics at different price points. It offers provision IOP storage for the most demanding workloads and both new and old generation general purpose storage for the less demanding workloads. Now that said, storage costs largely depend on the amount of data your workload is actually using, right? And how much storage you actually consume. And you can even configure RDS instances to expand storage automatically, right? And this is really, really useful because you don't have to provision those instances with the amount of storage you would use several years from now and then pay for a bunch of free space right now. Instead, you can provision these instances with an auto-expanding storage, and as your volume of data grows over time, you pay only for the storage that you use at that point in time. Optimizing the workload will also help here as well. Avoid unused indexes in the database. Use the smallest data types that can convey the value of the data. Don't store a textual yes or no in a column. Use a Boolean data type, for example. Implement data lifecycle management policies. Archive old, less frequently used data and put it in S3, for example.
Sounds good. So the storage is dynamic. It expands and contracts as needed. But even so, there are things you can do to make sure that you're optimizing your use of storage and the things that you mentioned about data types and proper use of textual data types and things like that, lifecycle management considerations. Aurora has a little bit of a different architecture from RDS because of the separation of compute and storage. So are there additional considerations with respect to Aurora storage?
So the workload optimization techniques I mentioned before certainly apply to Aurora as well. That said, in Aurora, you don't have to provision storage. It grows automatically as your data set grows, and unused storage can be reclaimed back. But for Aurora to be able to reclaim back storage, you have to optimize or compact your tables or delete partitions. simply deleting rows from a table is not enough for Aurora to be able to reclaim the free space. Nevertheless, it's a mechanism that you can use long term to actually adjust the amount of storage to the actual data set size. Now, with the release of Aurora IO Optimized configuration, either the IO Optimized configuration or the standard configuration may result in savings depending on how much throughput you consume. And you can, again, switch between these two configurations if your workload profile changes.
So, what about I/O cost optimization in Aurora? We talked about the new I/O optimized instances. If I'm not using an I/O optimized instance, are there things I can do to optimize my I/O costs?
Absolutely. There are different approaches for optimizing reads and writes in Aurora. Let's start with reads, for example, right? Reading of data from storage occurs whenever you're issuing a query and that data doesn't exist on the compute node in the cached memory. So the bigger that memory is on that instance and the more of your data set can fit in that instance memory, the less read IO you could potentially have to issue. So one way of actually kind of saving on IO cost is using bigger instances with more memory.
Mm-hmm.
Now, you can, of course, tune your queries to make sure that you're only fetching the right amount of data from the database, right? For example, scans tend to be very, very expensive on large tables because they traverse a lot of rows and they consume a lot of IO operations, and usually they only return 1 or 2 rows that you need. So tuning the workload, again, is very important. And there's other consideration on reads as well. If you if you use logical backups, for example, don't do that, right? The Aurora native backup and snapshot mechanisms are designed so that you can leverage those to restore your database at any given point in time, but they don't actually consume IO, whereas if you were to logically export that database, that will consume an excessive amount of reads as well. Now, on the writes side, a lot of the optimizations are already built into the Aurora engine. So Aurora groups concurrent writes, right, against the same pages and segments up to a size of 4 kilobytes into a single IO operation. So to the extent that you're changing data roughly in the same areas, you can optimize some of those writes as well. Now, workload optimization is, again, another aspect there. So removing unused indexes or, any other sort of duplicated data, or using, again, the smallest data types for your to express the data that you need in your data, in your tables. All of those aspects can have an impact on IO because they reduce the size of the rows and the number of IO operations by extension. And then the other aspect is logical replication. So if you don't use logical replication for anything right now, turn it off, because to enable logical replication in both Aurora MySQL and PostgreSQL, we have to write additional data to storage. And that additional data, of course, consumes write IO operations as well.
So you get some benefit just by turning it off when you're not using it. Cool.
Right, if the workload allows that, of course.
Cool. So Vlad, some of these cost optimizations are feature specific. And so can you speak to some of these feature specific cost optimization techniques in Aurora?
So my favorite feature here is Aurora Fast Clones. If you need to keep duplicate data sets, let's say you want to take a copy of your production database and spin it up in your development environment, right, to do testing and develop on a realistic data set. Or you plan to upgrade your database using blue-green deployments. For all of those use cases, you can create a clone of your database where the data itself is not physically duplicated unless it actually changes. you don't pay for a full additional copy of your data either. You only pay for the potential changes and differences that occur while you're using both the clone and the source database. And you can also create what we call a headless clone, right? These are Aurora clusters that don't have any compute capacity in them. So if you don't need that data set right away, you can simply just provision the clone, but don't put any compute capacity on it until you actually need it. And also keep in mind those clones can be recreated periodically, so you can sort of sync it back. Now, if you use global database as a way to kind of, because you need a low recovery point objective disaster recovery solution, consider using headless secondary region clusters as well. These are, again, clusters without compute instances. This means that in your DR region, you would only deploy the compute instances when you exercise your DR plan and cut over. Now, whether these optimizations is for you, it depends, of course, on your workload, right? And your recovery time objective, right? How short or long that is. If your RTO is measured in hours, this would definitely help. And speaking of DR, most customer DR strategies also involve a backup plan with periodic backups, typically daily, weekly, monthly, and so on, a combination of those. In Aurora, we have automated backups that can be used for point-in-time recovery, and they only accumulate backup storage costs for the data that changes during that backup retention period. And that's essentially incremental storage consumption. But snapshots in Aurora are full snapshots, and they essentially add a full copy of the data set with each one of your snapshots from a cost perspective. But that only happens after the snapshot creation time is older than the backup retention period. So in most cases, making the backup retention period as long as possible can actually save you on backup costs, even if you use snapshots. And that's true, especially if you need to keep daily or more frequent snapshots for your backup plan.
Great. So there are a lot of things. I can see why cloning is one of your favorite features. I like the way we implemented it. It's not a multiplicative factor in terms of storage when you clone, the way we implement it. And the global database being able to have storage capacity without any compute is something that would definitely reduce costs for DR purposes. So great stuff. Let's switch over to in-memory caching, Vlad. That's something that a lot of our customers use for cost optimization purposes. It's a very common use case for elastic cache. We talked about IO optimized instances and data tiering, et cetera. In-memory is another way that customers can get a huge benefit, not only in performance, and that's the one that most people think of is in-memory performance, but cost optimization is a huge use case here. Can you tell us a bit about caching as a cost optimization strategy?
Sure. Think about it this way. When you scale the database, you add more of everything: CPU, memory, network throughput, possibly even storage and I/O. But if you only need to add memory, then an external cache could be a great option. An external cache works well for read-heavy workloads and for caching large volumes of data in memory. Caching is also a great solution for use cases that require real-time data access, like gaming and session state data, or for frequently changing counters and leaderboards. An external cache can be significantly cheaper than scaling your database for the same workload. You only pay the per instance fee, and there's no separate I/O charges for Elasticache. The cache can scale independently from the database at a lower cost. And some recent Elasticache optimizations like enhanced I/O multiplexing and data tiering have significantly improved the price performance of using a cache. Now, since I mentioned data tiering provides a new price performance option for Redis workloads by utilizing lower cost solid state drives in each cluster node, in addition to storing the data in memory. And it's ideal for workloads that access up to 20% of their overall data set on a regular basis. When available memory is fully consumed on an Elasticache node, the service will use a least recently used algorithm to automatically move infrequently accessed items from memory to SSD. And this gives you a much better performance than retrieving that data from the shared network storage or perhaps from a source database. Your cost savings can be as much as 60%. And enhanced I/O multiplexing delivers a huge boost in latency and throughput for both Elasticache and memory on top of that.
Yeah, I mean, I'm looking at these numbers. Enhanced I/O multiplexing up to 72% better price performance, and data tiering 60% better price capacity. These are some pretty impressive numbers. So, what workloads can I use? Can I use caching with? Where it would be helpful.
Most read-heavy workloads, where the proportion of read operation is higher than that of the write, can be optimized to a certain degree using caching. Caches help most if your workload repeatedly reads the same data from the database over and over again. But you don't have to think purely in caching terms. In-memory databases like Elasticache and MemoryDB are great for workloads where the same data changes very frequently and where performing those changes in the regular database would consume a significant amount of resources due to the transactional overhead of a typical database. Say you operate a banking application, for example. You may want to store the session state of the user in memory because it changes frequently, but only for the duration of that session, only the time that that user interacts with that banking application. And that state usually isn't valuable past that point. Plus, you would otherwise have to keep your main database busy reading and updating the session state, which is not very efficient, right? So, leave the database to do what it does best, facilitate transactions in that, banking application example. But similar arguments can be made for other types of use cases like leaderboards in gaming, for example.
Yeah, so it has some broad applicability. In fact, in the past, people are used to thinking of caching on the basis of very limited data sets that needed frequent and low latency access. But the dynamics of that have changed. Memory's become cheaper and cache capacities have increased. So how much data can Elasticache realistically handle?
Elasticache can scale to multiple petabytes of data. As mentioned before, for the Redis-compatible in-memory services, Elasticache for Redis and MemoryDB, AWS also offers data tiering, which is a new price performance option that stores data locally on lower cost solid-state drives. Now, in addition, so you can scale the data set and optimize costs at the same time.
So all of our databases offer read replicas, and that's another way to scale reads, right? So how would I decide between read replicas and caching? Which should I use when?
Adding read replicas to scale reads is absolutely a viable option. And this works well when you want to scale the overall throughput and concurrency of reads from a database. When you have a high volume of reads, but you're not necessarily repeating the same reads over and over again. Caching is still better if you need low latency reads, sub-millisecond. Caching will give you ultra-fast read response time, that you cannot get from adding read replicas. But if you don't have such demanding response time requirements, adding read replicas is definitely a viable option for scaling reads. In general, from an application perspective, separating reads from writes gives you an advantage of scaling up reads independent of writes. You can add more read replicas. Most workloads tend to be read heavy, and you don't have to scale the primary database writer component. Now, keep in mind, with read replicas, you could end up creating replicas of the data that is not accessed often, right? If you use services like RDS, each replica is going to have its own independent storage. So you're also duplicating the amount of storage you're consuming whenever you're using read replicas.
Right. And so you may be replicating data that's not used very often.
Right.
Whereas with caching, by definition, you're caching data that is used often.
Correct.
So that's a huge benefit of caching. I would encourage our customers to look at caching as a cost optimization strategy. When you add up the numbers, you'll find that it makes a lot of sense in many cases. So please do have a look at this option for not just its performance benefits, which are well known in terms of in-memory performance, but cost optimization strategies as well. So switching over to data lifecycle decisions, Vlad, those can have a big impact on your overall cost profile. How do we charge for things like backups and snapshots, and what are some cost optimization strategies related to that?
Right. So we charge for the amount of backup storage used in a month. So essentially the cost of each gigabyte of backup data for a full month. Now, of course, it's going to be prorated if that amount of storage was stored for less than the full month. But one great thing about our managed database services is that you are not charged for the equivalent storage used, for the full size of your primary database. So if your Aurora DB cluster or RDS database instance uses 5 terabytes of storage, for example, the first 5 terabytes of backup storage are free. And then this is aggregated across all the databases you operate in every given region. In RDS, automated backups take a daily snapshot and then capture transaction logs approximately every 5 minutes. Each snapshot you take in Amazon RDS is incremental. So it's only capturing the differences from the previous one only. So as such, backups in RDS can be very economical if your data doesn't change much or frequently. Now, as I also called out earlier, Aurora and the other database engines relying on the similar storage technology like DocumentDB and Neptune take full snapshots each time. But those snapshots become billable only after the creation time is older than the backup retention period for automated backups. So in most cases, extending that backup retention period as much as possible will result in some cost efficiencies there. Of course, keep track of your snapshots, delete the ones that you don't need, and consider using a service like AWS Backup to orchestrate your backup plans so that you don't leave unnecessary snapshots behind that would add to your costs.
So there are a lot of things you can do here in terms of optimizing your costs with respect to backup and snapshots. I wanted to talk to you a bit about how I would figure out where to place my efforts. Which area should I be looking at in terms of cost optimization, and tracking cost metrics, and deciding where to pay attention?
So we aim to make it as easy as possible for customers to track their costs and stay informed in that area. And there are a variety of options to assist customers in this regard. I would start with the database services themselves. Many cost dimensions are presented as metrics in CloudWatch, just like any other observability metrics for your databases. So you can see the consumption almost in real time. Storage consumed, IO operations, generated by your Aurora database, for example, compute capacity consumed by your serverless databases, and so on. And then, of course, since that data is in CloudWatch, you can attach alarms to kind of monitor if they go outside of normal bound, what you would consider normal bounds. Tagging your database resources is key because you can then slice and dice the aggregate cost data later on by using these tags, as long as you activate them as cost allocation tags. I would also call out Trusted Advisor as a tool that performs a variety of health checks on your cloud environment. It has checks that will call out over and underutilized resources. So that's another way you can understand whether there's potentials for some cost optimization. The Cost Explorer tool in the AWS console provides dashboards to help you track costs. And those can be filtered down by service, resource types, and tags. And then finally, the cost and usage reports provide the most granular data on usage and costs. These reports are also structured to be machine readable. So you can build automations around them and interpret that data further as needed. But I'd be remiss not to call out the AWS pricing calculator. This tool is going to be your friend if you want to estimate or price out different configurations, different services, and even full solutions.
Great. So there's a lot of tooling available to help you figure out where you should focus your efforts, and you're not in the dark with respect to understanding your cost profile and sorting out where you can get the most bang for your effort. So that's been a lot of information, Vlad. Thank you so much. Definitely having an expert such as yourself has been very useful in this conversation. So I just have a few things to square off before we end. I would say that. Sorry.
Thank you so much.
Absolutely, my pleasure. I'm happy to do another session with you on this because there's so much to say about it. I would encourage our customers to understand your cost components and use the tooling we provide, and to get a full understanding of what's driving your costs. Use alerts and monitoring for abnormal changes. Do query optimizations on the top 10 intensive queries, and use tagging that we just talked about, for categorizing and understanding costs, and the usage report that Vlad just talked about, and reach out to our specialists. We can help. I also wanted to do a plug about a office hours session we're having on this very same topic. So you can ask questions today, but you can also come back and ask questions during these office hours that we'll hold on July 27th. And you can bring in your colleagues or ask additional questions that you haven't been able to ask, or just listen in to see what kind of questions other people ask. There's a list of resources here along the lines of the things that we talked about: pricing calculator, cost explorer, planning documents, etc. Lots of resources available to help you navigate this landscape of cost optimization. And with that, I would like to thank you for attending. Thank you, Vlad. And hope to talk to you again.
Thank you so much. Have a great rest of the day.
Cheers.